Ratios and rates. The first thing we need to refresh ourselves on is simplifying fractions. So if you'll remember, when we're asked to simplify fractions, you can find a number that goes into both the numerator and the denominator, or that the numerator and denominator are both divisible by. You can divide both the top and bottom by the same number, and then if it goes into it evenly, you will have a simplified fraction. So when you look at 3 over 9, you ask yourself, what number can go into both 3 and 9? The answer would be 3, so we can divide both the top and the bottom numbers by 3. Well, 3 divided by 3 is 1, and 9 divided by 3 is 3, so this can be simplified to 1/3. If you look at 15 and 25, 5 goes into both 15 and 25. 15 divided by 5 is 3, and 25 divided by 5 is 5. So simplified, it would be 3 over 5. When you look at the next one, we have 45 over 54. Both of these are divisible by 9. 45 divided by 9 is 5, and 54 divided by 9 is 6. And really quickly, sometimes you won't find the largest number that both numerator and denominator are divisible by. And so sometimes you might have to simplify several times to get the fraction in simplest form. If I could have done 3 with 45 and 54, I could have divided by 3 first, but then I would have ended up with a fraction that could still be simplified further. If you look at 26 over 42, a really easy thing to check for initially is if they're both even. In this case, both numbers are even, and when you have two even numbers, you know that they're always going to be divisible by 2, so that's a good place to start. When we have 26 over 42, actually the most that they can be simplified is dividing both top and bottom by 2, and you get 13 over 21. For 14 over 26, you're going to have the same case where 2 is the only thing that they're divisible by. So you're left with 7 over 13. And then last but not least, we look at 26 over 52. If you notice, 26 and 52 have a relationship between them. 26 can go into 52 2 times, and so if you can see that, that's going to obviously simplify the fraction very quickly for you. If you didn't see that right off the bat, you could divide both top and bottom by 2, but then when you check, there would be something else that could continue to go into both of those numbers in the numerator and the denominator. So simplified in the lowest terms possible, we would have 1 over 2. When we're talking about a ratio is going to be a comparison of two quantities. We have 3 different ways that we can write a ratio. The 3 ways are using the word to. So if I'm comparing 5 and 8, the ratio would be 5 to 8. I can write it as a fraction and put 5 over 8. It would still be read 5 to 8 as a ratio, but it's just written as a fraction. And then you can also write it using a semicolon. Again, it's still read 5 to 8, but this is another way that we can write a ratio. And I don't obviously have to be comparing 5 and 8. This will work with any numbers. So you can compare A to B. You can write it as A over B, and you can write it as A semicolon B. The most common way that we're going to see ratios written is as fractions, because the next thing that we're going to talk about is proportions, and when we're talking about proportions, we want our ratios to be as fractions. So almost everything that you see in my math class will be a ratio in the form of a fraction, but you could also write it using the word to or a semicolon. They all mean the same thing. It's just easier for us to work with ratios when they're written as fractions. Just like fractions, we can simplify the ratios if possible. In ratios, order does matter. So the first question asked me to write the ratio of stars to circles, meaning stars, the number of stars should come first, and we're comparing it to the number of circles, which should come second. So if you count the number of stars and the number of circles, when we're writing a ratio of stars to circles, it would be 8 to 6, or 8 over 6. If you notice, both of these numbers are even, and what I can do is I can divide both 8 and 6 by 2 and simplify this ratio to 4 over 3. And then the second question on this page asks me to write the ratio of circles to stars. Order does matter again. This time circles needs to come first. So circles would be on top, or the number of circles would be on top, and the number of stars would be on the bottom, which means that I would have the ratio of 6 to 8. Again, 6 and 8 do have a number that can go into both evenly, and it would simplify to 3 over 4. Dividing both 6 and 8 by 2 results in 3 over 4. In ratios, the two numbers you are comparing have to be in the same units. What I'm talking about when I say units is I'm talking about feet and inches, maybe yards, meters, centimeters. It could even be minutes, seconds, hours. So if I'm writing a ratio of time, let's say, I either need to be comparing hours to hours, minutes to minutes, or seconds to seconds. I'm not going to want a ratio that's comparing seconds to hours. So we're going to have to manipulate the measures to be in the same unit. What that's going to look like, it asks me to write the following ratios using the same units. In the first example, I have 30 seconds over 3 minutes. 30 seconds is not going to go to minutes very easily because 30 seconds is only half of a minute, so it would give me 0.5, and I really don't want a decimal or a fraction in the numerator or denominator of a ratio if I can help it. If you look at 3 minutes, though, it is going to be possible to get 3 minutes as seconds. We know that there are 60 seconds in 1 minute. So to figure out how many seconds would be in 3 minutes, I need to multiply the 3 minutes times 60, which would give me 30 seconds over 180 seconds. Notice 3 minutes and 180 seconds is the same amount of time. So I'm not changing how long we're talking about. I'm just changing the units that we're using to measure the time. If you look at 30 over 180, that can be simplified. 30 can actually go into both. So in this ratio in simplest form would be 1 over 6. The next one, we have 5 feet over 60 inches. If you'll remember, in a foot are 12 inches. So I can, actually this one works really well to change units either way. So if I wanted to go from feet to second, I would multiply however many feet I have by 12 to get inches, And then if I wanted to go from inches to feet, I would have to divide the number of inches by 12 to get how many feet. I'm going to choose to go ahead and multiply the 5 feet times 12 and convert 5 feet to 60 inches. Notice I have 60 inches over 60 inches, which is going to be simplified to just the whole number 1. And then last but not least, I have 10 minutes compared to 1 hour. This is kind of going to give me the same situation that I had above in the first example on this slide. 10 minutes is not going to go easily, and it's going to leave me with a decimal or a fraction to change 10 minutes to be in hours. So in this case, it's going to be way easier for me to change 1 hour, and 1 hour is 60 minutes. So I could compare 10 minutes to 60 minutes, which simplifies to 1 over 6. A unit rate is the rate for 1 unit of a given quality. A lot of times, if you go to the grocery store or if you're buying a car, questions that people would ask would be, how many miles per gallon does it get? Miles per gallon would be considered a unit rate because you're it tells you how many miles you can go on 1 gallon of gas. And a unit rate is a rate for 1 unit. In this case, our unit would be a gallon of gas. If you go to a grocery store, if you look at like buying bottled water, I'm a teacher, I buy pencils all the time. So if you look at packages of pencils, there's a wide variety. You can buy 6 pencils, you can buy 12 pencils, you can buy a pack of 24 or a pack of 72. And believe it or not, it does not cost the same amount per pencil depending on what package you buy. And so what you can do is you could take the price of the package divided by how many pencils you're actually getting, and you would figure out how much you're paying per pencil. The best deal on pencils is just an example that I use. The best deal on pencils is going to be the package that you can buy that you're spending the least amount of money per pencil. So you can take the price and you can divide it by how many you're getting, and that would tell you exactly how much you're paying for just the single pencil in each case. A key word to know you have a unit rate is per. So miles per gallon, I just talked about money or amount of money per pencil. If you think about miles per hour, that tells you how many miles you go in just 1 hour. So per is going to be a key word to know that you are talking about a unit rate. This last example says Kim drove her car 267 miles using 11 gallons of gas. Maddie drove her car 210 miles using 9 gallons of gas. Give the unit rate for each. I'm going to start first by going ahead and writing a ratio. The last question that we have to answer for this example says which car got more miles per gallon of gas. So I'm trying to figure out how many miles per gallon, which means the amount of miles that they drive has to go on top of my ratio, and then amount of gallons that they use needs to go on the bottom of my ratio. So for Kim, her ratio would be 267, and that's miles, over 11, and that was the gallons of gas that she used. For Maddie, it would be 210 over 9. So 210 was the miles that she drove, 9 was the number of gallons that she used. I need to find a unit rate for each, which means I need to go ahead and divide. If you're in my class, I say it all the time. If you need to change a fraction, or in this case a ratio, to a decimal, you're going to go ahead and you are going to put the top dog in the house, which means I'm going to divide 267 by 11. And when I do that, I get about 24.27 miles per gallon. That's what MPG stands for. And when I divide 210 divided by 9 for Maddie, I find that she goes 23.33 miles per gallon. So the last question says which car got more miles per gallon. Kim almost got 1 more mile per gallon than Maddie did. So Kim gets to go further on a single gallon of gas.